Okay, so fantastic. Thank you all so much for joining us for the first of this two-session workshop on expanding science with Rubin through collaborative networking, through undergrad research, with a sponsored lunch in between in this room. It's kind of dark and depressing. Sorry, we can also roam around a little bit. And the goal of the lunch is really just to encourage new connections, new collaborations, talking about things you want to talk about related to the session, not related to the session. That's just as much accomplishing our goals. If you find something you want to talk about that has nothing to do specifically with expanding networks, but you want to start a new science connection, a new software connection, that's all good here. So I'm just going to take a few minutes before turning things over to the real content of this session. Since we had a few more people come in, I'll also say, if you are able to connect to the Slack for this session, day two, to say 10:30 undergrad research 1, something like this, please go ahead and do connect to that, because I posted a link to an open shared document that anyone here should have edit access to and read access to, where we'll be, you can take notes, you can suggest questions for discussion, make observations, and we'll also be consulting that and using that as a document for later to help record the outcomes of this workshop. So you hear this at the beginning of every session, but it's very important at all times and all spaces to remind ourselves of the code of conduct. It's day 2. We've been here. We're also tired. It's important to keep our professional conduct and remind ourselves that there are resources if anybody experiences or witnesses any violation of our codes of conduct. I believe we're all used to the stickers on how we prefer to interact with each other. Remember this at the session, at the lunch in between, and during our discussions in terms of how close people are comfortable interacting with each other. Virtual participants, we are going to see how things go with the number of virtual participants. Right now, we're going to stick with all muted virtual participants during the meat of the session, and we'll see if we can do some creative things. I might try to do a Zoom breakout room if remote folks want to have discussion breakout session together. We'll cross that bridge when we come to it after the few talks we're going to hear this morning. Please, if you're in the room, speak into a mic unless you, for some reason, we really don't want anybody online to hear you, or even people in the audience who I always like to, even in the room, hear things through a microphone. We're going to be taking questions through Slack for this session. We also have somebody in the room who is monitoring the Zoom. So if you have issues or if you want to communicate questions via Zoom, that's an option for you as well. Okay, so the workshop goals here, and I got to this a little bit already for those of you who were able to see the plenary session this morning, were to share the power of collaborative networks and undergrad research as key factors for Rubin's ultimate scientific potential. A lot of us in this room, again, like-minded community, we love what we're doing. It makes us feel inspired. It helps our own individual research programs. It also is going to impact the overall scientific output of this extraordinary survey. I would love to come out of here at the end of the day, helped by our shared document, if everybody's a good sport and helps us add content to it, with concrete actions that can be taken in the Rubin community to improve partnerships, improve cohort building activities in a way that, again, helps us accomplish our goals of more Rubin science. Those concrete actions can be, you know what, we really need resources to do this thing. This thing is harder than we thought. Or it could be, we already have the tools and resources needed to do this thing. We just have to agree to do it. There's a wide range of things. And then to establish new connections, for us to meet new people, for us to find like-minded people that are excited to engage and build our own network. So we're gonna have some talks, we're gonna have some discussion time. So this morning, we're first going to hear from Mark Pitts to tell us about the Rubin Undergraduate Network. There's a web page now with the LSST Discovery Alliance page. If you go to our homepage and go to the Collaborate upper menu item, in addition to science collaborations, there's a RUN, an RUN network information page, which has a link to all you need and more on a website, but we're going to really want to hear what Mark has to say from his firsthand leadership experience there. Then, of course, it's going to be another treat to hear from Jesse Mason on his incredible work and collaboration with scientists at UMich Dearborn and Wayne State University outside of Detroit, pulling together a cohort of community college students to add value to research programs that are happening and who have gone on to present their work at meetings, including this in the American Astronomical Society. And then we'll hear from Leslie Hebb with input from John Bochansky, who are two of our members of the Expansion Partnership Program, where Discovery Alliance institutions can partner with primarily undergrad institutions or under-resourced institutions to come in and become full members through partnerships with paying institutions. Then we'll have some time to talk about what we want to talk about what we're thinking about after these talks, and then have lunch together. The lunch will be friendly to a wide variety of different dietary restrictions in case that's on your mind. I won't go through this in detail, but in the afternoon, we'll get to hear about specifically some cohort building, community building activities that are going on that are already starting to generate science. So I'm feeling so excited about every person that agreed to come and present at the session today. So before I hand things over to Mark, just reminding us of some context I already mentioned first thing this morning. Brilliance is everywhere and access to opportunity is not. So, right, the old school ways, there's a certain number of privileged ivory tower institutions, and they only hire the best of the best that come from the best of the best ivory tower institutions, and they have access to incredible observational resources and computational resources. But the fact of the matter is there's brilliance everywhere. And we want to access and unlock that brilliance by helping to spread that opportunity to more places, to more people. And it's well studied in the social science literature that diverse teams produce more innovative and well-cited science. I won't attempt to point to my favorite article or two. I'm sure folks in this room have their own, but it points to team diversity brings higher citation rates, broader visibility of research, more innovative research, increased long-term influence of research. So this isn't about privileged institutions need to help out the little guy because they need to be helped out. It's about mutual benefit all around from all parties. And the fact of the matter is, in the United States, most students aren't educated at R1 institutions. And so, you can take a look at these statistics itself, but nearly a third of undergraduates currently enrolled in the US are enrolled at two-year institutions. There's a huge untapped potential there that we'll hear Jesse talk a little bit about in his talk this morning. And of course, students in these different sorts of educational environments themselves are bringing very different lives outside of the classroom to the table that we need to bear in mind when encouraging those students that they belong and they can be excellent data scientists and researchers as well. And then finally, we're in a global community. There's people in 5 continents, 4, 5, 6, who Australia 6, who are doing Rubin science everywhere, but Antarctica, I'm sure there's people in Antarctica that are doing Rubin science as well. And so to really get the best ideas in the science field that you're interested in, we can't lose sight of the fact that the right colleagues and the right resources might not even be here. And so with that, I'm not going to take questions because no one's going to have questions on that. We will take questions after each of the talks. This is supposed to be fun, fairly leisurely. So Mark, come on up and we'll try to get your talk set. And are you comfortable using the hand mic or do you want to use the?
No, that's fine. Okay. All right. Hello. Welcome, everyone. Those of you who haven't met me before, my name is Mark Pitts. I'm a professor of physics and astronomy at Eastern Kentucky University, and I am here representing a larger group of undergrad-focused individuals known as the Rubin Undergraduate Network. So let me first give you our motivation, or one of our primary motivations here, has to do with unique challenges that are posed for undergraduates as opposed to graduate students and postdocs. These are elements that I'm sure you are very sensitive to, especially if you are at an institution that primarily serve as undergraduates. So little to no prior research experience, right? You're getting a fresh student kind of right out of the box. And so there's going to be a lot of things that you might accidentally assume that they know about the process that you have to kind of go back and make sure that you explain it to them. And on the other side, for the student, there might be some hesitancy in asking questions because they think they might be dumb questions or too obvious. Balancing research with significant course load, that's something that I had to deal with. And then also something that at my age, I didn't have to deal with. The amount of students that absolutely need employment funds to stay at their institutions is increasing, and it is huge. Often the employment can't even be academic, which is a bit of a shame. So there's a lot of time balancing going on, a lot of juggling. As Beth was mentioning earlier, a lot attending non-R1 institutions, okay? So not significant amounts of research funding available for them, especially for things like travel. Mentorship from faculty that may not have specific experience, right? You have a student who's really interested in astronomy, but it might be that their mentors are in a more adjacent field. Maybe they're more into engineering or physics, but they want to be able to support the student in their particular interests at the institution that they're at. And of course, limited time frame for completion. You get a student who comes to you and says, oh yeah, like I'm in my last semester before I graduate, but I'm really interested in this topic. And it's, oh boy, how do I come up with a project that's going to be like completed, started, finished, done with some product all in that time frame? That's a challenge. So with that motivation in mind, who are we? So we are a volunteer organization of faculty, staff, and postdocs from primarily undergraduate institutions, but that's not a requirement. And what we're really interested and what we're about is promotion of undergraduate astronomy research using data from the Rubin Observatory, that great fire hose that is just now starting to turn on. We have our own little logo, which tells you how serious we really are. And and thanks to one of our members, Lillian Joseph, for designing it. We noticed that whenever you put run meeting into Outlook calendar, it automatically put up a shoe. So we were just like, yeah, why not? So, and it serves with our acronym. So it all kind of worked out. So our mission, number one, offer guidance and supports to undergraduates seeking to perform substantive research projects involving Rubin data. That's the key word there. Number two, provide resources and a supportive community to mentors of undergraduates to allow them to effectively guide their students to a successful conclusion to their research projects. And then number three, this is the whole networking coming into play. Pool our collective knowledge, expertise, and resources to more efficiently tackle challenges unique to undergraduate research. There are a lot of undergrad-focused institutions out there. We want to make sure that we're not doubling or tripling up work where we could just get together and have it all done much more effectively and efficiently. Some examples of our current efforts. First off, to grow and sustain the organization. The first kind of inklings of this kind of network was actually back around, I believe, like 2023. Things coalesced a little bit more, in fact, after our workshop last year in 2024, and has been growing ever since. So we do now have monthly online meetings, and we are trying to increase the amount of presentations that we're giving at various astronomy get-togethers. And be aware, no membership fees. Anyone who works with undergraduate students is welcome to join. So there's no institutional requirements either. We are welcome to have you. Oh, it's back there. Yep. Yeah, it's all good. Next up, we are establishing an online presence. And at this point, I want to thank Beth in the LSST Discovery Alliance for giving us a home so that we can start to make our content more widely available, be able to advertise and get our name out there more effectively here. So if you have a QR code reader, feel free. Or as Beth said earlier, if you go to the main page for the Discovery Alliance and you go under Collaborate, we are now linked in from there. So it's really easy to get to our site. There's not a whole lot of material yet, but it is a start. In particular, you will find a list of some of our most active members along with contact information on that site. So feel free to have a look through that list, see if maybe you have some members already nearby. Another current project that we're working on, what we're referring to as the STARS project, trying to get creative with acronyms as we are apt to do as astronomers. The idea here is curated resources for the undergrad who has never done astronomy research before, in addition to something that their mentors who maybe have not mentored an undergraduate in astronomy research might find interesting and useful as well. These are inspired by the very well done set of Jupyter Notebook tutorials, as well as what is called the LSST Research Manual, which was developed to help answer undergraduates' questions about doing Rubin research. This was a project led by Marie Farwaz. This is also a link. They have their work put up online as well. They are from Henry Ford College. And this was a project that I learned about at this workshop last year. And said basically, oh my goodness, this is exactly the kind of stuff that I was interested in making. And it's great that we have this kind of starting point already. And that's one of the big ideas of this networking, is to find out who already has done or is thinking about doing what the kind of projects that you're already interested in, and no one has to reinvent the wheel. So some of our goals that we are trying to push for in the STARS project, we want the available tutorials, the Jupyter Notebooks, as they are designed now, are very well designed, is to instruct on the how of doing various types of data retrieval and analysis for Rubin. That's great. What we want to do is to provide some complementary guidance by focusing on the why. We want to provide scientific context for what all of these tasks are, and have a kind of curated guide that we can give to undergraduate researchers as to how and why they're doing the steps that they're doing. Kind of like a best practices kind of approach. As well as answering a lot of those obvious questions, right? If the student is too reticent, especially at the beginning of their journey, to ask questions about terminology or why steps are taken the way that they are in typical research, we want to be able to address those and make sure that those questions get answered. Integrating other non-astronomy specific resources, okay, Python guiding code guides and that kind of stuff. We don't want to just point to things. Instead, curating is the key word. We want to be able to very, very directly target very specific parts of perhaps other very well developed resources that are out there already, and say, no, you just need to look at this part for this purpose, or go here and just look at the guide in this area. Or if things are a bit too disparately formatted, might feel like a little whiplash, or like the student might get confused, to take some of that and reformat it to something that's more common on the website in front of them. Give them that a little bit more fluid experience so they don't feel like they're just being tossed into a deep end. Okay, just to give you an example, because I wanted to see what would happen, I had a student who was interested in learning about the Rubin data retrieval. So I threw the Jupyter Notebooks at them, no prior experience. I said, don't worry about it, just give me your impressions, right? Now, for purposes of getting that feedback for developing our stuff, that's useful, but that's ideally not something that we want to do. Okay, we don't want them to feel overwhelmed. So that's what this project is going to try to address. And finally, suggesting potential project ideas with expected products and time durations. You want to minimize that idea of, oh, we have an undergraduate, they're interested in astronomy research. Okay, well, so-and-so's got this huge project running. all right, they throw them in there, they do some busy work for them. That's it's useful, but they don't give them much context as to what they're going to do. And the products of that project are like 5 years down the road, they're going to be graduated before then. So they do this kind of drive-by research experience without the full, process. And then they go to grad school and they've never seen the full process before. So if you ask me what, in the ideal world at the end, what do I want to see? I would want to be able to direct undergraduates to our resources and say, okay, here's a particular project that says maybe that uses time resolved or differential photometry. And you can use here's a list of targets you could use. Here's how you're going to do your research. These are the steps that you want to go through. And here are the products that you will expect to get. And here's about how long it's going to take. Not just for the student's sake, but for mentors as well. To be able to say, okay, you have this much time, try one of these projects. And then they can have something that comes out the other end. They've now seen the entire research process from beginning to end, even though it's in a microcosm, but it's all there. Then you send them off to graduate school and you expand on it, right? You've seen it kind of in a nutshell in a much smaller context. Now you go to graduate school and it gets expanded, but you've seen all the basics already. You've seen the skeleton of what research looks like. Now you can start to put some flesh on there and really kind of hit the ground running. Okay. That's what I would like to see. As a quick example of kind of what we're starting to do in developing these wrappers for some of these notebook tutorials, I just grabbed a screenshot here of a example draft notebook that's being developed by another one of our Run members. Jacob, raise your hand right there. He's working on this. And again, so you might notice the first section here, introduction, right? It's good providing that context, okay? It's not about the how. The Jupyter tutorials always great. They're already there. They're great about the how. This is how you do something. But we want to start off with the introduction of why would you want to use this step? What's useful about it? What's it good for? What kind of projects might you be using this in, kind of thing. So again, it's all about that wrapper. It's about adding context. All right, aspirations for the future. Be great to have some financial support, I should say, for Rubin-related undergraduate research, for us to be able to just kind of direct undergrads to where those funding sources are, kind of have a nice up-to-date place where we can get that information out. And especially travel funding, because that's always one of the biggest kind of money sinks that's needed. Obtain financial backing for some of our active projects. Right now, we're 100% volunteer. And because of that, we have a lot of people that are very passionate about developing this kind of material and being able to draw in new members into the network. But when rubber hits the road and you want to really start to crank out things a little bit faster, that funding is really going to help. So that's something that we're going to look for in the future. And then finally, just to get the word out to as many undergraduate focused institutions as possible. Because again, we don't want to have some other institutions that are trying to do the exact same thing and we don't have any clue about the other. We want to be able to pool our resources so that we have that maximum kind of efficiency working on this thing. So we want to kind of just make sure that everyone knows that this network is here, it's growing, and it's all about just supporting our undergraduates in doing Rubin-related research. So if you'd like to know more, feel free to find us throughout the rest of the workshop. Here's some names from the people who are actually here in person this year. Some of them were able to provide some headshots as well. I know that I'm much better at recognizing faces than remembering names. So that's why I wanted to ask some people to put up some shots there. So have a look out and feel free to ask us about what's been going on. And if you'd like to join us, please do. We'll put you on the mailing list. We'll get you into our monthly meetings and also spread the word. All right. If you have people who are very passionate about undergraduate research using Rubin, let them know about us so that we can touch base with them and compare notes and hopefully work together on this. All right. So that's my talk, and let me know if you have any questions.
Okay, I'm bringing the mic to Lori Allen, to those of you who are online and can't see what's going on in the room.
Yes, it's a long walk. Thank you, Beth. Hi, I'm Lori Allen. I'm at Noir Lab, where I'm the director of the Mid-Scale Observatories program. That's Kit Peak and Sarah Tololo. So Mark, thank you for a really inspiring talk. That was very interesting. It occurs to me when you sort of led off with one of the challenges is creating a project that can be done from beginning to end in such a short period of time, as short as 3 months. And of course, the REU program does just that. And I was wondering, there must be really great synergies between the kind of program that you've created and the REU program. And I wonder if you've had those conversations with experienced REU leaders at some of the institutions where that program's been kind of an anchor for undergrads for a long time. Thank you.
Yeah, thanks for the question. I mean, yeah, that's a very obvious place for us to engage with. I will say that for myself, it hasn't really come up a lot yet in our meetings. I anticipate that it will as things kind of spread and the word gets out about us. It for no other reason than the fact that I myself did REUs when I was an undergraduate, and it really helped me a lot. And that challenge is still there because I think for both of my REUs that I had, it was a much more, here's this huge project. You're going to work on it for 3 months, and then you will present a poster on it. That's true. But I entered as things were already going strong on it. And when I left, there weren't any big findings yet because it was just a very large project. I don't want to disparage that to say that there's no value in that. But again, one of the things that we want to make sure that we focus on is that the undergraduates are able to see the entire process play out before they go to graduate school. So I would say that if people have experienced themselves or they know of people involved with the REU programs that have those more self-contained programs, yes, then please get us into contact with each other, because those are the types of projects that we would be interested in kind of letting everybody know about for those smaller undergraduate research institutions. So, yeah.
For the institutions I've been involved with, I would recommend the CFA program.
CFA, okay.
The CFA has had a really great REU program for a number of years. And I think they do make a real effort to make it a complete project in a short amount of time. I worked with several students there and it was very successful.
Okay.
We have time for one more question, and we'll take one question in the room. And again, if you're online, we will get your question answered asynchronously.
Yeah, Jesus Pando, DePaul University. I'm part of RUN, although I haven't attended very many meetings because I'm also a department chair. But you've spoken a lot about how this experience is going to help students get into graduate school, but graduate admissions are diving. Graduate schools, only 50% of students at most, right, go on to graduate school. So that's a lot of students that could benefit from this. And I'm wondering if we shouldn't also include a focus that helps students in their career, even if they're not going to graduate school, right? Instead of making clones of ourselves, which is what we tend to do, right? Let students have a different career path, because most students, frankly, are not going to get into graduate school. They're just, that's the nature of the world we live in now.
Yeah. And there's two things I would say to that, and I agree. So the first one is, of course, is that graduate school isn't for everybody. I mean, that's clearly the case. And I think one of the things that having a completed project arc can do for an undergraduates is letting them know whether this is something that they feel passionate about or not. If they've seen everything in a kind of a smaller microcosm kind of way, and then they're like, oh, it just doesn't seem to be my thing. I think that's really useful. The second thing, though, about those skills is, yes, that's something that I think mentors can really be effective in doing, is letting their students know what kind of transferable skills are involved with a given project so that they can be conscious of them when they are, say, just leaving college, and instead of going to graduate school, they're applying for jobs for the rest of their career. Is to let them know what kind of transferable skills they've actually seized on from doing this kind of work. So I think that's something that also we should probably emphasize when we are, say, presenting possible projects. Here are the transferable skills that students can get out of this.
Let's thank Mark one more time. And so as we're transferring over to Jesse's presentation, again, I want to thank those of you who have joined the collaborative document. If you're in there, yay, don't hesitate to add your name. Don't hesitate to add content. And I'll say that I've already thought, based on the presentation and the questions, of a couple cool discussion prompts for at the end. So I'm going to go ahead and add those into the document now if you want to take a look. So please, without further ado, let's hear from Jesse.
Good morning, everyone. My name is Jesse Mason, and I am absolutely thrilled to be here to tell you about my experience in facilitating research at Henry Ford College. Henry Ford College is a community college. I teach physics and astronomy there, and as a teacher, I would be bereft in my duties if I didn't give a pop quiz. So raise your hands right now if you've attended a community college. Okay, keep them up. Everyone look around. What is that, roughly 20% maybe? Do you know that roughly 50% of people that graduate with a bachelor degree in the United States have attended a community college? That's a wide disparity. We'll talk about that in a little bit. But first, we know we're amid a Cambrian explosion of data, and just as data is speciating, one of the main culprits is right there, science research needs to speciate as well. We must evolve our approach to doing science to address this torrent of data coming our way. I am happy to tell you that big help can come from small schools. My school is a small little school outside of Detroit. There's about 10,000 students, 4,000 of them are full-time. And the 8 students, plus myself and our lead researcher in this picture, belong to the Dead Star Society, which is our affectionate name for our research project. And yes, we have silly little rituals for our little secret society. These 8 students from last year's cohort were involved in a paper. They did research on attempting to find candidates for intermediate mass black holes. This culminated in the first of a series of papers. This one has been published in the Astrophysical Journal, and all 8 of those students are co-authors on that paper. This year's cohort is doing, pardon my graph here, they're doing research on neutron star Lomax X-ray binaries. They're using the Stingray software to do spectrotemporal analysis. And we are roughly 2,000 observations in on an 8,000 observation project. This is very heavy lifting coming from some students who are freshmen and sophomore in colleges. Mark did a really good job of characterizing the challenges of working, doing research with undergraduate students. It's even more bleak from a community college perspective. First, community colleges don't hire researchers on purpose, typically. I myself am not a researcher. I am now, in some sense, but I wasn't hired for my researching abilities. We are not compensated for doing research. We are not given redirected time for doing research. And so I don't even really have much time to do research. I personally teach 3 classes in person and 4 labs online. I have very little time in my week to even supervise my students. Fortunately, we've come up with a way to address that issue. This leads to a challenge where they don't encounter science in the most meaningful way, which is research. They do it through textbooks and through lectures. And their participation in the scientific community doesn't really happen until they matriculate into four-year or maybe even grad school. And as Mark said, a challenge is without that research background, it leads to them being less competitive in the grad school pool. Further, if we do attempt to do research at the community college level, resources online are not geared towards beginner students. Those manuals that we have found to do research, including the Jupyter Notebook tutorials, are mainly geared towards higher level undergrads or even grad students. And there's rarely even the physical explanations that they require to understand, well, what is this line of code actually doing? We happened upon a really great method for addressing this. I'll say more about this in a bit, and that is, instead of having the researchers write the guides, what if we have the students write the guides? The LSST quote unquote research manual that Mark was talking about was written by two of my students. I am going to give you what I think are the two keys for doing meaningful research at a community college level. The first of them is to find the collaborative structure you need. You really need a partnership between researchers at a four-year, it helps if it's local, and a willing facilitator at the community college level. And finally, you need supportive administrations at both. Typically, the community college administration says, go have fun, but the university says, why are you doing research with them? You should be doing research here. I have found that the two institutions that we have been working with have been phenomenally supportive, particularly when we intentionally create a pathway for transfer to those institutions, not just for them to transfer in, but to transfer and continue doing the research that they're doing with us. In other words, they can still be in the Dead Star Society when they matriculate into Wayne State University or University of Michigan, Dearborn. The faculty there have been incredibly supportive, and I saw Will on the Zoom, so hi, Will. We miss you here. The challenge in our area is that these are historically underfunded districts. As Mark said, especially at the community college level, having a job while going to school is not just for pocket change and going out, it's to pay for the school. It's really important for them. We have at my college afforded my students the ability to do research for their job. They are being paid to do research at Henry Ford College, and we're working on those opportunities at other nearby community colleges. So that's the collaborative structure I think we need. We happened upon what I think is an innovative workflow structure that unlocks a win-win scenario. Not only are we doing the noble thing of extending these research opportunities to students that direly need them, but we're actually going to provide the researchers with a benefit. We are going to save the researchers time. To do this, it involves an initial one-on-one tutorial, lasts a few hours, where they're learning how to do the analysis. Then they follow up with Slack or Zoom troubleshooting, and the structure I'm about to show you is in a paper under peer review at the Physics Teacher magazine, and hopefully be published soon. This structure is, I think, the key to unlocking an incredible latent research capacity in our country. There are roughly 7 times as many community colleges as R1 institutions, and those students hungry for research opportunities. I think this can help address that need while benefiting the researchers. We start by having the researcher teach a single student, we'll call it student learner 1, a particular process. That's the initial meeting. The researcher goes back to their institution, and learner 1 takes the notes from that session and writes a guide or a manual. This guide or manual becomes the sacred text for the process, but it's not done because it needs to be revised and improved, and it's done so through repeated processes. Learner 1, after mastering that process as best they can, has revised the guide, it gets better. Then learner 1 goes on to teach learner 2. This is the power of peer instruction. Learner 2, while engaging in the tutorial session with this Learner 1, will ask questions that are not addressed in the guide. Learner 1 will go back and fix the guide, so it includes the answers to those questions. Learner 2 masters this process, and in doing so encounters more questions, or as we have found, many errors in the code. Well, we need to explain those errors and what to do after. That improves the guide. Then Learner 2, notice, by the way, the researcher has been left in the dust. Learner 2 teaches Learner 3, and so on and so on. And every learning experience makes the guide better and better until the guide is no longer being revised, and we post it to our website, and it is the guide that we encourage other institutions to consider using when doing the process. That particular guide you're looking at right there is the guide we used to do our intermediate mass black hole project involving Chandra archival data. After that, Learner 1, or whichever learner is elected to go on to learn the next process, will meet with the researcher again. This is probably a few months later, and that researcher will spend another couple hours teaching them how to do the research process, the analysis process, and the whole thing starts over with a new guide. We're currently on our third guide on working with spectrotemporal analysis for the LMXBs. In summary, and you'll see this in the Physics Teacher magazine if you're a subscriber, you learn it, you do it, you write it, and then you teach it, then you recycle it. And those are the two keys. I hope that this inspires you to consider working with a local community college. And of course, I am more than happy to facilitate any sort of collaboration with your institutions, and would even be interested in collaborating with you on our research projects if you're interested. You can visit our website, our page that has the 3 guides I spoke of. It also has some contact information. And in conclusion, I do want to thank the LSSTDA and the Heisen-Simons Foundation for providing this remarkable opportunity for our students. And I hope that this sort of sets fire to the research opportunities across the country at community college levels. Thank you.
Great. Thank you so much, Jesse. Can we take some questions in the room to start for Jesse? I'll start with the question. So of the students that have participated in the Dead Stars Society, what have their trajectories looked like to date?
The most recent win was Courtney. She was one of the students in that large student picture. Courtney Reinhardt, also responsible for writing that, her and Anthony writing that first guide. She has earned the Jack Cook full ride scholarship to U of M Ann Arbor to study physics. Anthony is also at U of M Ann Arbor. Zainab Bustani, who did some work with radio data for a forthcoming paper on X-ray spectroscopy of our sources that we discovered. She is, I believe, a biochem student at next door U of M Dearborn, and Marie is transferring into U of M Dearborn as well to double major in physics and I believe biology. Yeah.
Excellent. Thank you so much, Jesse. Okay, now there's 4 questions, so many questions. Well, I'm going to go over to one of our student participants, invite her to ask the next question.
Hi, Jesse.
Hi, Kelly.
I was curious, how do you accommodate students who are not local into the program?
We have yet to have any distance learning students from Henry Ford College. We do have a few students that come over. Of course, they're not paid as Henry Ford students, but from U of M Dearborn that come over and do research with us. But to date, those are the only non-Henry Ford students that we've had. And the idea of incorporating somebody virtual is something we have talked about and we think we totally can do. In fact, I sort of anticipate that happening in the next few months. We're excited to see what challenges that presents, but I think as as I've showed you with this way of working through our process, our workflow, I think it can only make it stronger. So I'm excited for that challenge.
That would be very exciting. Thank you.
And I think I saw Aaron.
Thanks. Hi, Aaron Romanowski, San Jose State University. We're a PUI also, so a lot of experience with students with challenges that they want to do research, but they don't have. They're working a lot. So in order to have time for research, you have to carve out time somehow, either by course credit or being paid. And it sounds like probably you have foundation funding for your students. But I'm wondering if you scale this up to nationwide community colleges, what are the funding opportunities for those students?
I'll lead by saying the job that they apply for and get with the Dead Stars Society is paid for partially by college work study and partially by institutional funding. And I don't want to say caveat, but one aspect of their job that is written in, and I did this purposely to have incentive for the institution should they ever draw a question of, you have 10 students doing research and we're paying them all, it's quite expensive. They also have a small duty to help maintenance in the planetarium I run, help with some of the inventory and the physics stuff. It works out to be something like 2 or 3% of their overall time spent. So it's rare, but they are assistants and not just researchers. But a majority of their time they are doing research.
I actually had a question about, you said that it was that the students that you targeted were eager for research, but sometimes I feel with this population, what's so important is practical research for jobs at the end and convincing them that astronomy,
Yeah.
and that astronomy research will give them the practical skills they need is harder than I thought it would be. And I just wanted to get your thoughts on that and your experience and how much motivating did you have to do in the beginning? I mean, maybe now that your project is going, it's self-sustaining, but.
Well, okay, so the Dead Star Society has a reputation at my institution for being a very enjoyable experience, let's say. I do a lot of self-promotion of our group with our campus newspaper and the website. So there is a lot of visibility and they know about it. And when I reach out to students that I think would be well suited for the team, and this is strange, I just happen to have it with me. I give them this card with our logo designed by Marie Falaz. This says Dead Star Society. It says, you are invited. And on the back is a QR code that explains you're invited to apply for the job on the research team. So it's all the way, it's fun. When they join the research team, they get a token that was designed by Courtney Reinhardt, a 3D printed token. If they achieve anything like a 1-year anniversary, or they give a talk, or they are included on a publication, there's a token. It's a really fun group to be a part of, and they're incredibly supportive of each other. So we sort of have a reputation, and when the invitation goes out, the students are usually excited, and anybody can really apply. It's a job on campus, so anyone can apply. I have had to, let's see, with the students that are interested in being an astrophysicist, there's no convincing, they're excited. But if it's a student that has a different path, for example, I have a student that I knew could really use the experience, the transferable skills for his job path. He's going to be an automotive engineer, which is a big deal in Detroit. When I invited him, he was like, it sounds like a blast, but I was like, you're going to learn Python. You're going to learn to do complex data analysis. All of this is transferable to your career, and you'll probably be included on a publication for the data that we've been processing. So he took a little bit of convincing, but not much, and he's joining us next month.
Yeah, so I can imagine it's not a huge problem once you've developed those guidebooks to be able to pass them on to the next generation of your students at Henry Ford as you go from generation to generation, because there's that culture there. Have you been prodding the researchers on your partner institutions to promote those guides either on their campus or either on other campuses? Because I can imagine that's going to be more challenging to get
Actually,
those guides out.
That is what that's I think the biggest challenge I face as sort of the facilitator of this entire project, because we're at the point now where we're really happy with how things are running, how the workflow works. It's hyper productive. I don't know if I mentioned this, but our first researcher we worked with, Kristen Dage, told me that our contribution to her research cut her research time in half, which on a project that was going to last 2 years is a remarkable feat. Getting the guides out, I actually don't have a great idea for marketing for this kind of thing. And this is my call to action to everyone here. If you know a way that we can share these guides with other people, or if you know anybody that could use these guides, please do so. Everyone that we've worked with at the 2 institutions know these guides are there. So when we do relevant research, we're ready to go. I'll say that again for those of you who do relevant research. If you're doing relevant research, we're ready to go with those guides. The second thing is, I really want this model to be out there. I don't think this is a special thing where I'm involved, I'm any special, or even the Dead Stars. I actually think the Dead Stars is really special, but I think this model is special. This model can be used anywhere between a community college or a state college, or even an undergraduate institution for your in partnership with a grad school. It's a remarkably useful model. And if you see any use to it, please just steal it and go with it, because I think this is one way we can address the incredible amount of data coming our way, while also benefiting the people that could really use this help.
Great. Thank you so much. Let's thank Jesse one more time.
Thank you.
Okay, and we're moving on to the last talk of this session before we go into some breakout informal discussion. And after that Q&A and, oh, this is Keynote, do I play it? I'm going to add another possible discussion topic to our shared document there. I'd love to hear people talk about how we might, what's the next step? Like, what's the next scale up step from what Jesse just shared with us? Anyway, please, Leslie, take it away.
Oh, okay. Oh, thank you so much. I feel like so charged. My name is Leslie Hebb. I'm at Hobart and William Smith Colleges, which is a small liberal arts college in Western New York. And I'm really excited to be a part of this session. I'm kind of really charged up by the previous 2 talks. I spent a lot of time thinking about undergraduate teaching and undergraduate research, and I'm just excited about these 2 programs that got talked about. And so I'm going to talk about a LSSTDA program about partnerships between R1 institutions and PUIs like my institution. So I'm at Hobart William Smith Colleges, but I'm going to also talk about the collaboration between Rider University in Princeton, and John Bajanski, he's sitting right here, is the lead at Rider on that for that connection. So we are part of the Expansion Partnership Program, which is one of the LSSTDA programs that it offers. And it's the program is basically a standard LSSDA member institution in good standing may choose to confer membership to an expansion member at no additional cost to anyone. And the goal of this project is really what Beth has been talking about since the first plenary session, is to make LSST science accessible to research communities that aren't, that might not otherwise have the opportunity, and to increase the diversity of active LSS, member institutions, and expand Rubin science, basically. So I am collaborating with the University of Washington. So they are an LSSTDA member institution. They're a large Research One university. They have 40,000 undergraduates. They have an astronomy department with 25 faculty. They graduate 40 astronomy majors per year and a handful of graduate students per year. And they are a large research funding. They have a large research funding profile and research output with many postdocs. And I am at a small liberal arts college. I have about 2,000 undergraduates. There are no graduate students. I'm in a physics department with 5 faculty, and I'm the only astronomer. I also draw on the computer science department for some research students. So we have 3 computer science faculty that I sort of include as sort of faculty. We graduate a handful of physics majors a year, somewhere between, 5 and 10, and probably double the number of computer science majors a year. So we have a small research profile, and we usually don't have any postdocs, but we do have the opportunity to have postdocs if we had the funding to have a postdoc at our institution. And so the University of Washington sponsored HWS as its expansion partnership. And at the same time, Princeton University sponsored Rider University as its expansion partnership. So Princeton is a private research university. There's 6,000 undergraduates and 3,000 graduate students. It's a huge astronomy department with 30 faculty. They have large research funding and lots of postdocs. And then Rider University is a small regional university in New Jersey. It has about 3,200 undergraduates. There are no physics or astronomy department there. They have a computer science department with about 5 faculty and 1 astronomer in the computer science department. And they graduate about 50 computer science majors per year. And they have a small research profile as well. So the benefits of this LSSTDA program basically is that the faculty and students at the expansion institution, which is HWS and Rider, are exposed to the community of scientists and computational scientists and researchers and data analysts at the R1 and at meetings like the Rubin Community Workshop and the LSSTDA members meeting. In addition, as part of this program, once the connection is established, the expansion partner gets a $14,000 of kickoff funding. There's also 2 years, 2 times $5,000 of LSST related student travel to either visit the R1 institution or send the undergraduate students to a meeting. And then there's additional funding for the team to attend the face-to-face LSSTDA members meeting every year. In addition, the expansion partners can have preferred access to the LSSTDA programs, of which there's a Catalyst Fellowship program for postdocs, the Data Science Fellowship program for graduate students, the summer student programs and travel grants for undergraduates. There are Science Catalyst grants and Link Framework incubator grants and hackathons and computing workshops. So all of this is available as a benefit to the expansion partner at the smaller school. So for myself at Hobart and William Smith and John at Rider University, the goals for us are not always to send students to graduate school. We have a diverse set of goals. So I talked to John, and there's a lot of similarity here. I mean, one of the important things that we both want to do is expose our computer science and physics majors to large data sets, teach them data analysis skills, train them to use Python, Jupyter Notebooks, SQL, so that and all of those are for our practical skill building for their careers in whatever direction, whatever technical careers that they want. I also want to teach physics and astronomy classes with real world problems and real world data. So that's what I'm always looking for. John wants to explore machine learning in the context of Rubin. And I do have physics majors that some of them do want to become astronomers and go into graduate school. So I do want to identify potential astronomers. I get one every few years. And the other thing is really as faculty, not just for our students, but for us to stay connected and research active. So these were our goals for being part of the collaboration. And the application is really easy. It's a 1-2-page document that I wrote. It's called the Expansion Institution Status Request. And then I got together with my partner institution and wrote a 1 to 2-page expansion partnership plan. And then we asked the LSSTDA board for approval. And then it didn't take very long. It took 6 months or a few months. And then we were approved, and now we're part of the program and get all the benefits and try to meet our goals. So just to say the successes so far, both myself and my partner at the University of Washington and John and his partner at Princeton attended the LSSTDA face-to-face meeting last year. And then we both attend the monthly LSSTDA Zoom meetings and are at the community workshop. We also have this access to the Rubin tools and the cloud computing that allows a high level of research at small institutions without access to R1-like funding and infrastructure. So it's really important, just the nature of the way Rubin is trying to do science, which makes lots of things accessible and inclusive, really does help allow a small institution like ours to do high level research. So having access to all of the tutorials on the Rubin Science platform and to be able to use the notebooks and access the data in the cloud environment, which was set up through the LINC frameworks, is really instrumental. Like, we don't need a big computing space at my institution. It's all done by the computational scientists developing tools for Rubin. And then as part of this program, I was able to hire 2 research students to work on Rubin data this summer. We made a research visit to the University of Washington in June 2024 to connect with our expansion partner. The stipend for the student salary was paid by my institution, and then the travel funding to go to the University of Washington was paid by the LSSTDA expansion grant. And so the success there, one of my students, Jonathan Holmes, he's a math and computer science major at HWS, and he connected with a researcher at the University of Washington and identified a project to detect and measure properties of satellite trails. So instead of a kind of astronomy project, because he's not a physics or astronomy major, he was sort of interested in the mathematical and technical aspect of measuring satellite trails. And I think it was a little more approachable as a research topic for him. And I'm really excited about the choice that he made. And Ryan Jackson, he's a physics major at HWS, is going to work on orbital properties of newly discovered Rubin asteroids because he's interested in orbital mechanics and learning Python and things like that. So these were some of our successes so far. And some of our struggles, just to say, my students and the students at my students they just finished their first year of college and they haven't had an astronomy class. And John's students are CS majors, so they don't know a lot of astronomy concepts. So they have to learn astronomy concepts like what is, modified Julian date and what are these UGR IZY filters, as well as how to write in Python and how to use this Rubin Science platform. And so that has really been a challenge. It's also because they're either young or not quite astronomers. It's hard for them to figure out what to be curious about because they just lack domain knowledge. And it was something that I can't remember if it was Mark or Jesse that said, the notebooks are good at how to do something, but the why is, we want to make sure we include that. And so that has been something that we've experienced. Like, it's hard for them to understand, why am I doing this, even though it tells me how exactly to. As part of this project, I decided to expand my own research interests and get interested in asteroids and planetary science, because a lot of my students come in thinking about astronomy in the solar system, not astronomy beyond that. And so I've been entering a new area of research as well. So I'm not as familiar with it. I can't support them in the same kind of way. And I am also learning the Rubin Science platform with the students. So again, things are going more slowly. My students unfortunately couldn't attend the workshop this year, but hopefully next year. And the last thing that makes it challenging, but for everyone at a PUI, like our main jobs are teaching and surface expectations, and we just have limited time for research. Like John was saying, he taught 5 courses last year. He developed a whole new program in computer science, and he was the chair of his department. And so all of that, I mean, we all know that, but it's not always part of our job to do research, and so it has to be carved out. So these are some of our struggles, but so far I feel really great about this program, and it's been a success so far, and I'm just excited to be part of this community. And that's it.
Time for 1 or 2 quick questions of Leslie before we go into breakout discussions, and we have David Rathfelder here. For those of you online, we'll set up a breakout room so people joining remotely can have your own breakout discussion while we're doing so in the room. So any questions for Leslie or John? Okay, I'm walking over to hand the mic to Kelly here.
I was just curious what it would take to add astronomy classes into the college. Even the College of Staten Island, we kind of lack in astronomy classes, and this is a direction that most, some want to go in. So how do you include that in colleges that do not have?
Well, for me, it's not hard. I mean, we do have astronomy classes. My students this summer just hadn't taken them because they're relatively young. The challenge, and then for John, you can say something.
Yeah, so at my institution, it is a challenge, mostly because the demand has to already be there. To be specific, essentially, we need 9 students in a class per semester for that course to run. And so it's a little bit of a chicken and egg situation, because if you don't have the student population already in place without the courses, then how do you get the courses to start running? And so it's a challenge. It's not unique among smaller institutions, but it definitely makes the progress and the identification of potential students a little more challenging.
Okay, let's thank Leslie and John one more time before we go into discussion. Okay, thank you so much. So we're going to have parallel breakout discussion sessions. So David is coming up. Those of you on Zoom, hang in there. David, can you put everybody in the same breakout room who's online? And then, let's see, is it a huge amount of people? Oh, no, it's a good. Yeah, and I think a couple are in the room here. And so then for folks online, I would love it if you could grab on to any of the themes or discussion questions in the shared notes and take notes on your discussion. We may not have time to come back for report outs. We'll see how it goes, but if not, we will do so in the second part of the workshop after lunch. In the room here, there's been a number of ideas for discussion added to the shared notes. And so I'm going to try something which might not work, and we'll try something else if it doesn't work. Is there anyone in the room particularly excited to discuss a specific question, who wants to identify yourself and say what the question is? And then if we can identify a few, then maybe we can sort of accrete nodes of discussion within the room. So I'll take a pause to let people contemplate the opportunity to identify what you'd most like to talk about right now. And yes, I was a liberal arts college professor, so I have capacity for silence. We have a hand.
So there was some discussion about distributing stuff and how we get stuff out there. And so it just occurred to me that we might look at GitHub as a possibility. So if there's some people who would be interested in somehow combining efforts to use GitHub to start curating guides and things like that.
Okay, so I'm going to take Jennifer's excellent prompt and I'm going to just expand it out a little bit with some other notes that I saw on here. And I'm going to suggest that if Jennifer would like to find a spot in the back of the room, and anybody who wants to jump into that does. So Jennifer suggested, how can we use GitHub and some other technical tools to help with some of the themes that we've heard about, whether it's disseminating resources or otherwise. I think it's also interesting, maybe I'll take that a step further, are some of the technical resources that we've heard about in other sessions, like the Link Framework's Python project template, or even some, handfuls of hours from folks with software engineering expertise. Might there be opportunities there to set up infrastructure and frameworks to make it easier or low barrier of entry? So anybody interested to talk about technical tools to facilitate both dissemination and on-ramps to undergrad research? How about we're going to go ahead and collect back there, and no pressure, you might be like, I want to hear all the questions. So that doesn't mean Jennifer's question is not popular. Lori, would you like to add a question? Well, then you're going to be sitting in that area, which Jennifer's a nucleus. I don't know. I don't do hacking. You'll do people call it. This is the accretion part of the discussion where we accrete on. Are there any other themes that people, we've got two here. So we're going to hear from Pat and then Willow.
I think it'd be interesting to discuss how we can message to undergraduates why it would be significant for them to get involved in research, and maybe significant is not the right word, but that the goals in exposing them to research go beyond the PhD. Because especially, I think first-gen low-income students, which I was one, that's not why I did research, because I didn't even, it was only by doing research did I realize I would want to do a PhD. And so that would not have been the message for me. It was more that the professor approaching and saying, would you like to do research with me? Well, what's that? So messaging, because I think there's so many other reasons to expose students to research. So I think brainstorming on all those different reasons that go beyond preparation for a PhD, because like people said, just the numbers are, we overtrain, but we don't overtrain students, but that's not the only really important thing they can do in society.
Thank you so much, Pat. So folks interested in talking about that, and if I could expand that, how do we message to the students? And then maybe even when you decide on the messaging, how do you influence the program or the experience based on that messaging and your goals? So people are going to nucleate around Pat, who will find another spot in the room, who want to discuss that. And so let's hear from Willow.
Hello, thank you, Beth. I was looking at these discussion questions and I saw one: how do we emphasize to students that the full arc of the research projects that they engage in? And I found that really interesting because I started doing research at a research university just after my first year. And so now I guess I've been doing research for about 8 or 9 years. And it probably took me about 5 full years to understand the environment that I was in for that long. And part of it was because I was a student taking classes and doing other things, but I'm interested to know what other people have to say about that sort of problem, and how do we communicate to students, what are you actually doing? What is the goal, and what is the environment that you are working in?
That's great. And I hear Willow suggest a discussion topic connecting with some of the other themes as well, where how do we teach students that context and that sort of more bird's eye view of what they're doing, which could potentially retain and engage students earlier on than if they have to wait for years to see that. And so I'm going to suggest we nucleate with Willow around that. Before we break into groups, I'm going to pause to see if there's anybody else that is willing to be a nucleus, or anybody who's thinking, gosh, the thing I wanted to talk about that's not connected to these themes of the holistic, full understanding of research context for undergrads. How do we communicate the wide range and acknowledge the wide range of trajectories? And how can we contemplate technical tools as tools for dissemination and for on-ramping? Oh, two more. Okay, we haven't heard from Alma yet. I'll pass to Alma.
Thank you. So I have been always very impressed of all these programs that works for undergraduates here in the US with Rubin. But I wonder how can we make other programs outside of the US where students will not have access directly to Rubin data. They will have to wait until data is public. And so, yeah, I would like to discuss ideas of what can be done in advance without Rubin data, but helping doing these research projects. I know there is platforms like the Citizen Science and so on, but I feel like you have to be waiting to somebody else create this project there, and it's not like a effort directed to undergraduates in specific countries. Yeah.
Thank you, Alma. And we're going to have another discussion question in the second half of the workshop. So let's cap it at those four. And if you just are sitting next to someone, you want to talk about something else, go bananas, right? And so I'm going to expand Alma's prompt a bit to say overall, like we've heard so much, but it's all been US based plus data rights based. And so how can we possibly take some of these lessons and bring them to international settings, either without or with data rights? Because there's different sorts of, institutional priorities and structures again. And so Alma will be the nucleus for discussion of undergraduate research in places which may or may not have data rights or, is not happening in the US. So everybody find a spot. We're just going to maybe talk for 15 minutes. If you can, take notes. I know that Will, you're online, Pat's online, a few things that come out of the discussions, and then we'll break for lunch in just a little bit. Okay, great.